Hello guys, welcome back. Today we are going to discuss the problem jump game 2. Okay, I think yesterday I discussed the problem jump game 1. This problem is similar to that, but it has a small change. First, let's go through the problem. You're given a zero indexed array of integers nums of length n. You are initially positioned at nums of 0. Each element nums of I represent the maximum length of a forward jump from index I. In other words, if you are at nums of I, you can jump to any nums of I plus j where 0 less than j less than nums of I and I plus j less than n. Return the minimum number of jumps to reach nums of n minus 1. The test cases are generated such that you can reach nums of n minus 1. Okay, let me explain the question first. Okay, you are initially given an array which is zero indexed. Okay, you start its indexing from zero and you are initially located at position zero. Your primary goal is to reach the last index. That means you have to move from the first index to last index in the following ways. Okay, as you were said that you are in the first index, you could take jumps. Okay, jump like this from one element to another element like this. By jumping from one index to another index, you could reach the end of the array. But there's a process for jumping. In each jump, you can only jump to the index. You can only jump to the index which is just array of I from this. Okay, let me elaborate this. If you take 2, the maximum jump distance from this element is 2. That means either you can jump to 3 or you can jump to 1. That's it. If you consider 3 here, you can jump to 1, you can jump to 1 or here, and you could jump to 4. I think you understood this. Okay, if not, I'll explain you once. Okay, the jump from an index can be denoted as the maximum positions from which we could jump. Okay, from 3 we could jump to 4 or to 1 or to 1. Okay, this jump length is 1 and this jump length is 2 and this jump length is 3. In such a way we could jump from elements. Now let me explain the solution. Okay, we are given that the test cases are generated in such a way that you could reach nums of n minus 1. Okay, the problem here is we could reach n minus 1 in any way, but we need to find the minimum number of steps to reach the last index. So what I'm doing is, first I'm starting from the first index, right? I'm checking each and every possibility. Okay, initially I have 2, right? Okay, there's one branch. From 2 I could take one jump or I could take two jumps. Okay, if I take one jump, then I would encounter 3 over there. Third element, right? From there, I could take one jump, I could take two jumps, I could take three jumps. If I take one jump, I would encounter one. If I take two jumps, I would also again encounter one. Like this. One, two, and three. If I encounter four, okay, if I take three jumps, I have reached the last index here. So I'd store this possibility in in an array which is called dp. Okay, we use that for memoization is nothing but storing some dp of n. I store this value in this array. Again, let's check the possibilities for 2. If I take two jumps initially, I would reach the number 1. Okay, I already recorded this for number 1, right? If I go for number 1, I would take one jump again, then I would reach 1 again. From there, if I take one jump, I'd reach 4. From here, if I take one jump, I'd reach 4. So instead of repeating this process again for 1, as I said earlier, I'm storing these values in the array called dp. I could easily call that, and I take all the possibilities in which we are reaching the end of the array. Like, let me give a possibility: 2 to 3 and 3 to 4. This is one possibility. The next one is 2 to 1 and 1 to 1 and 1 to 4. These two are the possibilities. In this possibility, we are only taking 2 jumps, whereas in this, we are taking 3 jumps. So, my minimum is this. Basically, I'm checking all the paths using recursion and just finding the minimum steps of them. Okay, which takes the minimum steps to complete. Okay, let's get into the code. You would get a familiar understanding. Or again, in a case, if I encounter 0 anywhere, like this, I just simply return that the path cannot be. That means we cannot reach to that path. Okay, we need not write a special case for that. It could be covered. Initially, I'm considering an array, a global array, as dp, right? And I'm allocating some space for that. I'm assigning each and every value in the vector or so-called array with the maximum size, the maximum integer possible. Okay, I tell that in few more minutes. Why did I took that? Let's write. Let us take the function name as jump and then s comma the current index. As we are starting from the first index, I'm taking here it as 0. And, and now, if I reach the last index or greater than that, I'm gonna return 0 simply. This is our base case. And now, if dp of r, sorry, dp of I, if I already stored that the value of that index in my dp array, simply I could return that, right? Now, if these both cases fail, now I'm performing all types of jumps. I'm taking a separate variable for this. It's not so necessary, but for neatness, for concise code, I'm taking. Okay, I forgot. Okay, I forgot adding another case here. I think it's not necessary, but first let us add and check that or if nums of I equal to 0, then also that's not a possible path, right? So, oh, we couldn't reach the end of the path. Oh, we need not do that. Sorry. If ju of next, we are checking the ith index from here. So kth index I plus k. And another specific thing is this could be large. Okay, the maximum size of the array is 10 power 4. And if we keep on adding up to 10 power 4 values, it could cross the maximum integer size. So just I am dividing it by 10 power 5 so that we wouldn't get an integer overflow. Now I am updating it to the TP as we need the minimum value. I think you might have understood why I took every element of the DP as in max. This is because I'm taking the minimum value. If I would have kept that as 0 or 1, 0 or 1 would be the minimum value for each and every step. So I kept it. Let's run the code and check whether it's working. Oh sorry. I just Please excuse me for my coding errors. As this is my second video, I'm just rectifying my mistakes one by one. Okay. This got the accepted and the runtime is 0 milliseconds. Let's submit this and check this. Yes, the solution is accepted. Thank you guys for watching my video. If you don't understand any point, please let me know in the comment section so that I can clarify your doubt. Please like the video, share it and subscribe to my channel Worship Tech Talks. Thank you.